I want to go over a few Linux commands that are very useful for people who are actually doing penetration testing and also for those who are working in a security-oriented Linux environment. Now, this is part of the Attack Defense Labs, and the section, or more specifically, this scenario is called Lesser Known Hacks, part of the Linux Security Linux Basics. Interesting, funny way how they actually categorize them. And they say that it's easy level. So let's actually start this and see where we're going. I also have the lab manual here because the point, this is not actually a challenge. This is something that all of us have something to learn from. So the objective, it says, to be honest, I've actually gone over them yesterday because I thought whether or not this would be a good video. So some of them might not be actually very intuitive, but more likely very counterintuitive. And myself, who has actually been working in a Linux environment, especially for automation and most specifically for penetration testing, I've also done a lot of scripts that help me in my automation when I do bug bounties, which is every more or less now and then. So I'm actually doing them less and less, and most of them that I'm actually doing them on Synac. So some of them, like I said, are interesting, which is why I thought it might be useful for those of you who are more towards intermediate level, not necessarily beginner level. In this case, it says use Python to start a web server in the present working directory. Let me actually make sure we're recording here and I'm not actually speaking by myself. So yeah, 2 minutes in. Use Python to start a web server in the present working directory. That's actually really simple. And what I want to specify here is that I'm going to actually interject or interfere alongside, because there wouldn't be any originality to the video if I just copy paste what's here. So I'm gonna try to add my own twist to everything that I'm doing. Open another terminal and do a curl request to it. View bash command history. That's pretty simple. That's actually history. Anyways, fire a command and make sure it is not captured in the bash command history. Now, this is something that I haven't done because I haven't, in my work and in my projects, I haven't been doing a lot of evading or evasion techniques, and I haven't tested Windows environments. So I suck at Windows. And for that matter, I also suck at evasion, because most of the stuff that I'm doing, are the penetration tests that I'm doing, are for network, for mobile assets, for web assets. A lot of it has to do with source code review, and a lot of it is in burp. So it doesn't actually have a lot of stuff to do with evading unless a client specifies it so. Okay, list all lines of file in reverse order. Well, this is interesting. Delete all content of a file with one line command. And this can be done in multiple ways. Write output of a command to 3 files at the same time. Generate MD5 or SHA-1 hash of a file. Find previous fire commands from bash history using reverse search. I didn't know about this one. Check information of a file. Use a screen to preserve the console output and running tasks in case of connection breaks. This is actually something that I'm doing a lot in my penetration tests, and also in some of the bug bounties. I'm using screen, and I'm going to show you my twist on it. Now, we've got the lab link. The lab is started, so let's go over and see what it is all about. We also have the walkthrough here. So use Python to start a web server in the present working directory. Let me actually make this one bigger for you so that you can actually see it better. The first thing we have to do to start a Python web server. Now, depending on the version, we can say which Python, user bin Python. If we fire up Python, we can see it's Python 2.7.6, 16. We can exit from Python, and then to actually start, there are multiple ways. In Python 3, you can do Python, for example, if you've set the environment so that Python 3. Let's say 9 runs a Python file, you can actually specify that Python 3.9 minus m and then http.server. But in Python 2, I would say Python minus m simple http, and let's see if this is how we're doing it. Simple http server to fire the server, and then you can actually start the port, let's say 8001 for example, serving on http port 8001. But first, let's see, maybe they want to access, they also want to create a dummy index HTML and start a Python web server. So let's actually quit this, clear this, and say echo hello cyber, and we echo this into index.html. But let's actually first see what's our present working directory. We're in the root. Let's go to var dub. We don't have that kind of thing. Let's actually go to, let's see, who am I? I'm root. Let's actually go to home, or just ls home. No such file, ls. Let's do ls home. We have the student. Anyway, it doesn't matter. What I want to say is that echo hello cyber into index.html, and then we're gonna start the Python web server. But first we gotta know what's our IP address so that we can actually run it, or we can simply copy this link and go to index.html. But first, let's actually look at IPADD. We can do IPADDR, or we can also do curl IPADDR.io. This might not work because maybe the machines aren't allowed to communicate with the internet. I'm not actually really sure how they specified this. So yeah, it doesn't want to communicate. What we can do then is just simply start the simple HTTP server on port 8001, and then we can actually just go to index.html. We have 404 not found. Interesting, and we don't have anything here. So yeah, because we aren't on port 8001, so we have to specify the port 8001 index.html, and there is nothing in there. Okay, let's look at the walkthrough, what they say. They say it on port 80. They specify it on port 80, so if I don't do anything, just let it like that. Let's do port 80, and if we go here to port 80, it says 404. But if we start another instance, let's actually do another instance, and then we say curl localhost 80/index.html, we get the hello cyber. So we might not be able to access this from the outer internet, but we can access it from the local host. What does it say? Check the open socket using netstat. Regardless, they use curl. Alright, so number two, view bash command history. That's actually quite simple. So bash command history, you just say history, and then you see everything that I've typed in there. This is very useful. I find that this that running a history is useful for me when I actually run very long bash one-liners and I have to sometimes type it again. I just do history and then grep for, let's say, HTTP, and it's going to give me something along the line. So I'm using history combined with grep to actually search through my history. Number 3, fire a command and make sure it's not captured in the bash history. Now this is something that I didn't know. If a space is typed before the command, the bash history won't log it. So we have 17 lines in the history. So in that case, if we space, as you can note that one more time, space, let's say let's run netstat. We get the netstat, and then if we run the history, we don't see any netstat. So grep.netstat, there's nothing in there. Other than that, we can actually use their example space date and then history. We will be looking at the last command, and it's gonna be history probably. Yeah. So that's interesting. Whenever you're testing and you might be wanting to evade detection, this is one useful way to actually do it. There are multiple ways, and you can combine them all together, but if you just run space before your command will actually run. However, it won't be logged into history. What if we chain commands? So let's say space date, then we can chain the command saying netstat, not like that, but just space netstat. So we have space date and then another command space netstat, command not found. What if we do, let's actually look at the history again. It hasn't been logged. So one more time. What was it? It's not even there. So space date, and we say end space netstat, netstat command not found. But if I do and it's not also, so I'm actually clicking the upper arrow, and in this case it doesn't show. So if I do space date and netstat, it actually runs, and it's probably in the history. It's not in the history. So good point. It doesn't matter, apparently it doesn't matter how many commands you're chaining, because if you start the first command with a space, we can say netstat, then we can say ps, then we can say what else can we say, present working directory, then we can say, let's actually chain them with semicolon. Let's say another command, which is uname. So we have all of them, all of the commands have run Sunday, so date, netstat, and then we have the ps, which is here, then we have the present working directory, which is there, and the uname, which is Linux. Now if we do history, we should hopefully not see this command here. So let's do history, and the command is not there, and if I do the upper arrow, it's not even here. So really interesting. Something new that we learned today is that if you start a space with one or multiple chained commands, nothing will be in the history. List all lines of a file in reverse order, last line first. So the cat utility is to print the contents of a file, and then you use the tac utility, TAC, to actually list all lines. So you list the lines, but just in reverse orders. So from the last one to the new one. So if we do cat @c password, we get this, and if we do tac @c password, we can do, we're actually getting the, where is it? Cannot see where it started. So we've got the root. Let's actually clear this, and we do tac @c password. So they're printed in reverse order. the tag utility can be used to print the file in reverse order. So in this case, we can simply just say if we want to cat add c password. If we don't want to use the reverse order, we can say cat add, or just not cat, but tail add c password. We are given the last 2, 4, 6, 8, 10 lines. But if we say tail minus n5 add c password, we're getting the last 5. But in this case, we don't have them in reverse order. We just have the last 5 of them. So in this particular sense, tail would be useful. Likewise, tag, you should be aware of it if you want to see something from reverse. If you want to print something from reverse, you can do tag your file and then reversed add c password, and that's how you actually print it in reverse. No point in doing that here. Next, delete all contents of a file with one line command. A simple black input redirection black can blank the file, copy a text file and remove its content. So let's actually, how many minutes? 60 minutes we're in. Let's actually copy, or we can simply cat add c password into let's say underscore password, and then we look into here, we have the password, cat underscore password, we have the add c password, a simple black input redirection. So it says you would blank the file, you would delete its entire content by doing this into underscore password. If we do cat password now, there's nothing in it. But if we repeat our command here, we then cat underscore password, and then you could simply echo nothing into underscore password, and then there's nothing in password again, except in this case you have a new line, I guess. It's the same thing, but I'm not really sure what type of scenario would be applied to this sort of situation. But anyways, this may not be one of the lesser known hacks. Write output of a command to 3 files at the same time, and they're actually using the T utility, and I use it a lot in my automation. So for example, we can where were we? We can cat add c password, and then we say T, so the output of this command is put in a new file. We can say file 1, file 2, and file 3. So this is actually going to put all 3 of them up. It's going to put the contents of add c password in all 3 of them. But for example, if you have a file that's already there, you could specify the -a. So if you have an existing file and you want to append to that file, you would use T-A. Now in this case, let's do just that. File 1, file 2, file 3. Okay, and it also outputs it to the screen. We have file 1, file 2, file 3. We can say cat file 1, file 1, file 2, file 3. We can do a word count on all files, and all of them have 21 lines. So you do the word count, and you can see that all of them have the same number of lines. Now, if you do cat add c password T-A file 1, you could simply say not cat but tag, and then if you do a word count -L on file 1, you're gonna see it's 42. If we cat it, you can see it in reverse probably. So root all the way up to student, teacher, I mean all the way up to teacher, then from teacher in reverse using the tag all the way up to root. Alright, so I guess you get the point. The idea is to use T. Generate MD5 or SHA-1 hash of a file. This is very useful when you're actually looking to check the integrity of something. You can do this in you can MD5 something in Windows as well, but I'm not actually really sure what was it in Windows. MD5 sum is not MD5 sum, is I don't remember what was in Windows. MD5 terminal Windows cert util. So you're actually using the cert util. Let's see. Yeah, so you're actually using the cert util minus hash file. And you specify the type of hash at the end of the file. So in this case, if we do an, can you do echo? I don't remember. Yeah, you can do echo this into file.txt. If we do type file.txt, we have this, and it's all spelled out with the quotes. Now, if we use cert util hash file file.txt md5, we get the md5, and if we do SHA-1, you have the SHA-1. Now, if we echo this into file.txt, we do type file.txt, we have this. If we run the cert util again for SHA-1, we can see that both of them have changed. So this one is different from this one, and this one is different from this one. If we do the same thing here, clear md5, let's actually remove -r file, all of them, the index, and also the password. Now let's do echo this into file.txt, cat file.txt. Now md5 sum this, I mean file.txt. Let's see if it matches. It should match because we have a new line here. So if we echo -e, a new line, into file.txt, and then we cat file.txt, we have two new lines. Let's actually remove one line. How do we do that? We can simply echo -e this new line into file.txt and then cat it again, and in this case we should be able to have the same md5 as previously, so as in the Windows environment, but you might be surprised that they are not. I wonder why. Do we have nano here? We don't have nano. Do we have vim? We do have vim. Let's actually vim this. Vim file.txt, and then what was it? So this is all the contents of the file. We do this. Cat file.txt. One more time. You get the same MD5 sum, SHA1 sum file.txt. You have the SHA1. So they are different from Windows, and the point of this video is not to actually understand why. I'm pretty sure there's a solid reason for this, even though the content might appear to be the same at a first glance. There's something that I'm missing, but I don't know why. Now, moving on. Find previous fired commands from bash history using reverse search. This is something I didn't know. So recursive search on the bash history, you have to press Ctrl+R and then you do a reverse search on history. So clear Ctrl+R, that's exactly what I hit. And then I think this is sort of like autocomplete. Let's see. We've typed netstat, right? And as you can see over here, it starts auto-completing. We've also did date or not. Reverse search. Control R, date. Interesting. Doesn't seem to work as specified. Control R, D, A, T, E. Maybe I didn't do date. Let's actually look. Let's do PWD. We have PWD. Now let's history grep date. There's nothing in there, but if I do now date, it should be in there, and if I do Control R and then date, we have date. So it was my mistake in this case. So you can do reverse search in your history via Control R. It's basically the same thing if you do history with the grep. It's exactly what I've shown you before. Check the information of a file, and this is done using the file. So file.txt, it's an ASCII text. Let's see if we do have the file. File is not recognized in Windows. Okay, so file @c password. It's an ASCII. File ---- help. We have a lot of things that we can do with the file. The same thing. Use a screen to preserve the console output and running tasks in case of connection. Alright, so this is the final section, and I'm actually going to only show you my twist on it. We're not going to go, because I think this is more simpler that what I want to show you. So let's actually clear this. Now, for example, right now we're running only one instance. I can use screen. So for example, let's say that I'm connected to my VPS using some sort of a PuTTY or directly via SSH VPS so VPS, let's say root@vps.com. Let's say I'm logging to that using my SSH, and my password. If I start something in there, let's say for example, if I start FUF in my instance and for some reason my internet disconnects from the SSH, then my entire FUF is going to be destroyed. But I can prevent that using the screen functionality. And the screen functionality is not only to prevent sessions to be destroyed, but also to actually run multiple things when the only access you have to something, you don't have a GUI access, but you only have a terminal access. Now in this case, let's say I want to run multiple commands. In this case, I want to run FUF in one instance. I want to run, let's say, dirbuster or dirb and nmap. So I would require actually opening 3 of these in in the browser in this case. So in one of them it would be FUF, in the next one here is going to be derb, and in the third one is going to be nmap. Now, I can do that, of course, but for to actually save some space, not only physically but also mentally, I can simply do screen. And in this case, I would start a new screen session using, let's say, I use the -s and I specify the name of the session. Now, first, before we do that, we can do a -ls, and we don't have any screen session running right now. If I do screen -s, and then let's say session, let's say I call it ses1, it's going to put me into another session. We are still root, and we can do, let's say, bash. Alright, and now let's say I would want to run fuf http://example.com. Let's say I run this command in here, and then I want to exit. I want to actually not necessarily exit, but detach myself from the session. This is the magic word, detach. Not really sure if this actually works in the browser, but to actually detach from the session, you hit Control+A+D. So I'm actually going to try to hit Control+A+D right now. As you can see, I might have been detached. Clear. I think I am detached from the session, but we can check that using screen -ls. We can see that we have ses1 over there. It's running. Now, what I can do, I could simply just close this one, and my fuf instance would still be there, hopefully. I'm not really sure how they've managed to set up these browser cloud environments. So if we do screen -ls, yes, there is. To actually attach to that screen, I'm using screen X and the session, the name of the session. And we are back into the session. We can use Control-AD one more time, and then clear, and then screen into another session, let's say ses2. In ses2, we'll be running derb, https://example.com, and then once again Control-AD to remove, to actually detach from the session. We can start screen -s ses3, and in session 3 we can run nmap localhost. We're actually going to run this, nmap not found, bash nmap, we don't have nmap, ipaddr, we do have ipaddr, Control-A+D to detach from the session, clear this. We're going to look at the number of sessions we have. So we have 3 sessions. All of them are detached. Now we can attach to each one of them with the -x. Let's say ses2. We're attaching to the session, and then if we do exit, this is going to kill the session. If we do a screen -ls, we only have session 1 and session 3. Now, this is the very basic of screen. You can just do screen -help, and it's actually going to tell you all of its capabilities. Or you can do man screen, I believe. You will still need to ensure packages installed. So it might not be installed, but you can do a man on the screen to actually look into the manual of the screen. Let's actually detach from the other two. You could also, let's say, I think you could screen -x to actually kill it. Let's see. Execute command. Screen -x ses3 exit. We need to specify the session with its full path to 19. Use -s. So -x, let's actually do it like this. Screen -s, or let's say just -x ses3 -x exit. it didn't actually work. But if we run it one more time, interesting. Let's resume SAS3. It didn't run the command. Control AD, screen minus ls. So screen minus s 219 SAS3 minus x, exit. Screen minus ls, it's still there. Screen minus minus help. Execute command as a screen command in the specified session. What if we do minus x, exit? Use minus s to specify SAS3. You need to specify it with the full path. (201) SAS1. So maybe we need to specify the minus s 201 SAS1, then minus x, exit. It says it ran, but it probably didn't. Screen minus minus help, grep kill, grep terminate, grep exit, nothing. Grep nothing. Wipe. Now regardless, I think I've made my point. So the idea is that you can attach SAS3 and then exit. Exit one more time. Clear, clear, clear. Screen minus ls. And you would also kill this one. Screen minus x, and when you have only one session running, you don't need to specify its name. It's actually going to simply resume the session, and then we can exit twice. Control C, clear, and right now there are no screens running. All right, so I guess these have been a few commands that are helpful when you're actually doing a lot of work inside a Linux terminal.